Okay, so I did a little bit of stuff with you guys on polyatomic ions. Also did some stuff on how to name acids. Now let's put these things all together in terms of naming stuff. All right, so when you get a compound or you get a formula, the first thing you got to look at is what's the first element. That'll tell you what category to put the thing in first. If it starts off with a metal, it's going to be ionic. Now, the rest of it could be a polyatomic ion or it could be something else, but that's the naming system we're going to be in. What if it starts off with a hydrogen? Actually, I'm going to move that down to the end. Let's do this instead. If it starts off with a nonmetal, okay, that means it's covalently bonded. And that's got its own naming system. What if it starts off with hydrogen? That means it's an acid. They're trying to tell you, hey, the activity we're looking at for this compound, if we start off with a hydrogen, it's an acid. That's what I want you to know. That's what we're trying to look at. There's another category here. What if it starts off with a carbon? That's an organic compound. They pulled that out of AP because we used to have to spend a whole week on that stuff, and we said, hey, this is not worth it because you got to learn that anyway. So on the AP exam, any organic compounds, so they start off with carbon and have other stuff, so carbon and hydrogens usually, they will give you the name and the formula and usually even the structural formula, so see all the stuff is bonded together. Okay, so we need to take a look at these two things. I want to do this one real quick. If we start off with a non-metal, it's a pretty easy thing to deal with. You've got all kinds of ratios with this. With ionic compounds, it's all about the positive and negative charges and making those balance, so we got to know what the charges on everything is to get things right. If it's covalently bonded, you've got a lot of different possibilities. For example, these are both different compounds that exist for nitrogen and oxygen. There's actually about 5 of them. What do you do when you're naming this stuff? Well, as soon as you get the covalently bonded stuff, you just got to use the prefixes. And you might want to write that down on your page if you have trouble with it. It goes mono, di, tri, tetra, then it's penta, hexa, hepta, octa, nona, deca. It's all in your book. You can write that down if you want to, if you have any trouble remembering that. It's the same, a lot of the same prefixes as we use in geometry. So what we have to say with this? Well, so you'd have to say nitrogen dioxide. Could you say mononitrogen dioxide? Yes. There's a weird rule in there though. If the first element only has 1, you don't have to put a prefix on it. But if you say mononitrogen dioxide, that's really not problematic. How would you name this one? It's very important. This right here is laughing gas. This stuff is very toxic, poisonous gas. Probably in the dentist's office, you don't want them mixing these two things up. So now I've got 2 nitrogens, so I have to say dinitrogen. Dinitrogen pentoxide, and that gives you the right formula. Now, is it pentaoxide or pentoxide? I've asked a lot of people on this that are professors, and they said it doesn't really matter. As long as you get the pent on there, they don't care if you keep the A or not. Probably need a linguist to figure that out a little bit better. One of the things, too, is the second element, you change if you got what we call binary compounds. So that's 2 different elements. The first element, you just use the name of the element. Might need a prefix if it's covalently bonded. The second element, you just always change the ending to IDE. And you get some weird sounding stuff for you until you're used to it, like iodide rather than iodine. Okay, so that's it for that. Now, one of the questions that comes in there, well, what about if you got a metal bonded to a metal rather than a metal bonded to a non-metal? Metals bonded to metals are alloys. We're going to cover that during the year, but they don't really have formulas. It's just percentages because there's a lot of different combinations they can be in. So that's kind of a whole different ballgame. So what do? Well, the metal part you just name. So let's say I've got this guy. Okay, what's the metal I have starting off with? It's just sodium. It is not disodium, okay? The prefixes are exclusively reserved for use with these things right here, okay? This is all about the charges. Sodium has a +1 charge, sulfur has a -2 charge, so that's the only formula I can get for sodium sulfide. Again, the ending changes to IDE. Well, what happens if I have this instead? Obviously, I can't name that the same thing. So if you see more than 2 elements, and the first one is a polyatomic ion, and there is an exception to that, and I'll talk about the positive ions. There's only one positive ion you have to know. But anyway, you've got a metal, so we know it's ionic. It's got more than one element, so, oh, hey, there's a polyatomic ion in there. All you have to do is name the first ion in there, so sodium, and then you throw on the polyatomic ion. There you have it. Okay, there is one caveat that you have to have with this stuff. Group 1s and group 2s are always +1 or +2 charge, no exceptions to that, so you don't need to tell what the charge is. Some of the aluminum is always +3 as well. Some of the transition metals have more than one possible oxidation number, so what you need to do is, in Roman numerals, you've got to put in what the charge of that what that charge of the metal ion is. Otherwise, a person won't know which version of that you're talking about. So let me show you that real quick, and that'll kind of finish this off. Let's get rid of this. This is something that probably gives students more trouble than anything else. These are both iron oxide, iron oxide. They are not the same compound, so we have to have a way of telling us apart. What we care about usually with these things is what the charge is. A lot of the stuff we do is in solution, so the ions, the positive and negative, will split up, and then we really need to know what the charge is on this. How do you figure that out? Well, you have to take the charge that's on the non-metal to figure out what the charge in the original thing was. Oxygen has a -2 charge. You're supposed to know how to be able to do that using the periodic table. So start with the noble gases are 0, and work backwards. All the halogens are -1, oxygen, everything under that's -2, etc. So we'll say iron. There's only one iron right here, so it has to have a +2 charge, and that has to go in parentheses. So that's iron 2 oxide. You have to do this. I know it's a pain in the butt, but you don't have a choice. You can't get the wrong compound when we're doing stuff. This one obviously has a different charge. Well, oxygen still has a -2 charge, but there's 3 of them. So the total negative charge is -6. What does the total positive charge have to be? Well, it's +6. Okay, well, +6 charge, 2 different atoms. What must the charge be on each atom or ion? It's got to be +3. So you'd have to name this iron 3 oxide. There you go. That does that for this. One more thing though, so there's a couple things that you need to memorize as well. You are going to need to know this polyatomic ion. Sorry to throw that in randomly, I should have put it with the other thing, but I'll remind you tomorrow. That's hydroxide. We're not going to have any trouble remembering this. You're going to be using hydroxide by the end of the year till you're blue in the face. It's such a common thing. You also have to know our one common positively charged polyatomic ion, which is ammonium. So you can get like ammonium nitrate and stuff, which is quite explosive, so that's kind of a deal. This is different than ammonia, and they want you to know the difference on that as well. That's NH3. World's worst 3 there, but you get the idea. Ammonia, I know this is confusing, but that's a gas that can exist on its own. It's quite toxic. Ammonium is a polyatomic ion that's in quite a few ionic compounds. Okay, so that does it for everything I want to do with naming. Have your notes. I know this is more videos than I'm usually going to have you watch. Take those. Everybody should get 100, and everyone will have an A+ starting tomorrow. You may not have your computer to look stuff up. I'm going to do some stuff to make sure that doesn't happen, but you can use anything you want off your notes. If you don't like these, you can use the textbook instead and make up your own. All right, I'll see you tomorrow.